So first thing to do is to write on your paper. So first, this is geometry. It's semester 2. This is the first unit, trigonometry. That's why it says 01 trigonometry. And this is called 09 trig practice. It's down in the trig practice bonus at the bottom of the unit on the table of contents on creatormath.com. So you go to creatormath.com, click the geometry tab, and then scroll down to trigonometry, and then you'll find trig practice. So for these are practice problems on trig, and I'm going to run through them as quickly as I can. I'll use the calculator on some, but not on all. So for the following figure, what is the proper setup to use for the cosine trig function? So one of the things about trig is it's hard to decide which function to use. If they're already telling us cosine trig function, it makes it a lot easier, but don't forget our memory device. We have so, we have ka, okay, so, ka, and toa. And you say it all together like SOHCAHTOA. Everybody repeat after me, SOHCAHTOA. So this one is cosine. The cosine is adjleg over height. So we're going to have cosine alpha equals adjleg over height. All right. We're dealing with this angle here. That's the reference angle. So it's going to be alpha. We don't know what it is. So we've got cosine alpha equals, adjleg is this one. That's the leg attached, adjacent, or next to the angle in question. So 7 over 15. Right, so cosine alpha equals 7 over 15. Then they want us to reverse it and find the alpha here. So we're going to say alpha equals cosine comes over here and has a negative 1 and 7 over 15. All right, and if we're going to put that into the calculator, let's see if we can do that. Remember that your calculator looks a certain way when your phone is in portrait mode. You're going to need to rotate your phone landscape to get the calculator to come up. And then you're going to have the whole trig calculator. Right? So if we're trying to put in this thing here, we're going to have cosine to the negative 1, right, which is the reverse, or arc cosine. So we're going to do second arc cosine, parentheses, 7 divided by 15. Type that in. I'm going to close with the parentheses, and it looks like I have 2 parentheses there, interestingly. And 62.18 degrees. 62.18 degrees is our approximate answer. All right, let's see the next one. So what's the measure of angle A? Angle A is over here. Let's put an alpha in for angle A. We have a side across from this, and we also have another angle aside from this. So this is going to be law of sines. We have sine of A over A equals sine of B over B. And sine of A we don't know, so it's going to be sine of alpha over the side across from that's 5 equals sine of B is 102 degrees, so sine of 102 divided by 7, which is side across from it, or opposite. We're going to multiply both sides by 5. Here. These are going to cross out. We're going to get sine alpha equals this. Actually, I'm going to go ahead and move the sine over. Let's move the sine over to the other side and say sine to the negative 1, the inverse sine, and move this whole thing down into here, which is sine 102 times 5 all over 7. So alpha is going to be approximately equal to, let's clear this out, say sine to the negative 1 of another sine, so switch to sine of 102, 102 degrees, close the parentheses, times 5, divided by 7, close the parentheses. So it looks like the angle here is 44.32 degrees, 44.32 degrees, and it's approximately equal because we're cutting off all the decimals. Let's go to the next one. So this one says, for the following figure, what's the proper setup using the tangent trig function? They're telling us the functions on these, which I'm kind of not happy about, kind of like to figure them out myself. But if we have TOA, tangent alpha equals op leg over adj leg. A-D-J leg. And we know that because it's TOA, right? Tangent equals op leg over adj leg. Tan, we have an angle in this case of 27 degrees equals, so adj leg is here, that's the adjacent leg, is x. So that's going to be on the bottom of the fraction because that's adj leg. The top is the opposite side, which is 14, so that goes here. We're going to multiply both sides by x. That'll cancel out the x from the right. Divide both sides by tangent 27 degrees. Here, these are going to cancel. So we're going to get x equals 14 divided by 10, 27. And let's see if we can go ahead and just do, I'm going to go ahead and do that straight away, if I can fit this on. So let's clear this out. This is equal to 14 divided by tan 27. Tan 27 degrees. Close the parentheses, and we get 27.48. 27.48. And that's the length of this side here. 27.48 would be the length of this side. So let's find side BC. BC's here. Looks like we have a side length, an angle. I've got a side length across from an angle here, so that's opposite. So it looks like law of sines, but notice there's no angle here across here. So we first need to find that third angle. The way to do that is take 180 degrees, because the sum of the angles of a triangle are 180 degrees, minus this 38, minus 92. Okay, so let's do that. 180, clear this out. 180 minus 38 minus 92. Looks like 50 degrees. So this one's going to be 50 degrees here, right? This is 50 degrees. We now have sine A. Let's write this out. We now have sine A over A equals sine B over B. And let's go ahead and plug in and say, let's make this side x. So let's do sine 38 over x. Sine 38 over x equals, sine B will be this one, sine 50, over this side across from it or opposite, which is 10. All right, let's multiply both sides by x. That'll cross out the x's. Actually, I don't want to do that. I don't want to divide both sides by x's. I want to keep the x here. I want to divide both sides by sine 38. And here and here. Sine 38. So just these will cancel out. We'll be left with x is equal to sine 50 over, the 10 is on the bottom and the sine 38 is here. There, clean it up a little bit. We're going to get an x is approximately equal to, clear this out, we're going to say sine 50, close the parentheses, divided by, whoops, try it again, sine 50, close the parentheses, there we go, divided by 10, also divided by sine 38, sine 38 parentheses. I'm not totally sure I like the way that's coming out. Let's go ahead and say sine 50, let's put a parentheses around these, here, and here. It's given us a very small size of 0.047, right? Not sure I like that at all. Let's make sure we've got it set up right. Sine of A over A. So we did sine of, we know we're 50 degrees here, sine of A, so sine of 38 over x. Ah, okay, let's go back. Sine 38, let's scribble this out for a second. Let's go sine 38 over x is equal to sine 50 over 10. I do like multiplying both sides by x again. Let's multiply both sides by x here and here. And sorry I'm getting so messy on this one. That will cancel out the x's here. Let's multiply both sides by 10 here. get rid of the tens. Let's divide both sides by sine 50. Sine 50, those will cancel out. All right, so not happy about the way I'm making this look for you. I apologize. We're going to have x is approximately equal to, here's a 10, times the sine 38 remains, divided by the sine 50. Okay, my deepest apologies for that messiness. And all of you like to do math in pencil, that's your reason, right? You can erase it all. Or in pencil, you can erase all the pencil, but I like doing it in pen, it's just more fun for me. 10 times sine of 38, close the parentheses, now we say divided by sine of 50, close the parentheses. So 8.04, x, this one's equals, x is approximately equal to 8.04. Right? I like that a lot better, and why did I start to think it was wrong? Because how can a side be 0.04 long? When this side's 10 long, this side can't be that small. It just doesn't make any sense, right? So maybe this is good modeling on how to catch a mistake. You know, I'm looking at this thing going, I got a little bit too messy here, so something went wrong. I know this is wrong. But 8 makes a lot more sense for how long that side is. All right, let's go to the next. So for the following figure, what's the proper setup of the tangent trig function? So tan is TOA again. Tangent alpha equals op leg over adj leg. Tan of the angle, we don't know it, it's unknown. The adj leg is here 7 and the op leg is here 15. So op leg is 15 over 7. I'm going to say alpha, move the tangent over and reverse it, so like a reverse function of 15 over 7. A little bit easier to put into my calculator maybe. Oops, go this way, there we go. So let's clear. Let's go to tan negative 1, because we got right here tan to the negative 1. Arctan's called. 15 divided by 7. 15 divided by 7 parentheses. So 64.98. Alright, so here we have the inverse. 15 over 7, I like that. It's this one. And I like this answer, 64.98, for the actual measure of this angle, 64.98 degrees. And don't worry about the time, you guys. You can go ahead and log off, and I will see you next time. Okay? I'm going to try to keep going on this. Let's see what I got. Yeah, I can finish these. This one says, for the following figure, set up the cosine functions. Remember, cosine alpha equals, and now we're at ka, right? So, ka, toa. Ka is adj leg over, oops, hype. Let me get hype in there. Cosine of 27 degrees equals, adj leg is 5, so this is 5 over, hypotenuse is this one, the longest side and across from the largest angle, it's an x. So let's plug in an x here. I'm going to multiply both sides by the x, right? Cross out here and divide both sides by the cosine 27. 27 degrees. These cancel, so I'm going to get x is equal to a 5 over cosine 27 degrees. Here we go. I'm going to get x is approximately equal to, clear this out, and say 5 divided by cosine 27. Switch back, cosine 27, 5.61. And that's how long this side is here. So if this is 5, it makes sense that the hypotenuse is longer at least. That part makes sense to me, 5.61. Move to the next. What's the length of side AC? AC is across here. I'm going to call it A, because I can tell already this is a law of Cosines Rule. So remember, for law of cosines, A squared equals B squared plus C squared minus 2BC cosine of the angle across from this. So right there's across or opposite. And I'm going to find this A length of this side, AC. So let's say A squared equals, either of these can be B or C. 14 squared plus 18 squared minus 2 times b, which is 14 times 18 again, times cosine of the angle, which in this case is 140 degrees. I'm going to take square root of the left, which will cancel that out, and take square root of the right. So A is going to be approximately equal to, and I'm going to plug this all into my calculator in one statement if I can, because that's going to be the easiest and cleanest, believe it or not. Clear this out, do a square root. That stands for the symbol over the whole thing. Then let's put 14 squared plus 18 squared minus 2 times 14 and 18 again. 14 times 18. And it's going to be cosine of 140 degrees, so cosine 140, parentheses, and parentheses. That'll close in this whole thing here. Notice we have 30.10. 30.10. Okay, approximately equal to, because we're truncating the terms. So if this is 18 and this is 14, this one's 30. Why? Look at how wide the angle is. This actually makes sense to me in terms of when I'm looking at the overall triangle. All right? And you guys, it's 9:50, so if you got to go, you do. Go ahead and go to your next, and I'll see you next time, all right? This one says, for the following figure, what is the proper setup using the tangent function? Again, they're telling us the function. How would I know it's tangent? Because I've got an op leg and an adj leg. And tan alpha equals op leg over adj leg. And it's the only thing I don't like about this assignment right now is it would be nice if they took this out and just let us figure that out for ourselves. Maybe I'll modify that for next time. All right. So we have an angle, tan 27 degrees equals, op leg is 14 over x. This is going to be x right here. That's adj leg. Let's multiply both sides by x. Let's divide both sides by tan 27. You do to one side, you must do to the other. These are gone because they're 1. Tan 27 over tan 27 is 1. X is going to be equal to, so what, the x's are gone. We have 14 over tan 27. So x is approximately equal to, get this on, let's make sure my calculator flips. Clear this out and say 14 divided by tan 27. Parentheses, even though it's not necessary. 27.48. 27.48. Notice they just want to know, is this the setup here? We had tan alpha equals 14 over x. That's our setup, right? And we've gone the next length and actually solved for the side. All right, what's the length of side BC? Here's BC here. So this looks like another law of cosines here, because we're looking for an, let's call this A. We have a B and a C, and we have an included angle. So let's do A squared equals B squared plus C squared minus 2BC cosine of A, which will be 65. A squared equals 25 squared plus 15 squared minus 2 times 25 times 15 times cosine of 65 degrees. And take square root of the left, that'll get rid of that. Take a square root of the right, what you do to one side you must do the other. Get my calculator in here. Let's clear this out. Let's do a square root on the whole thing. And let's say 25 squared plus 15 squared minus 2 times 25 and 15 times, and that's not 25, let's get that right. So 25 squared minus 2 times, I need a times 25. There we go. Move to the right, times cosine of 65. All right, parentheses and parentheses, 23.09. So A is approximately equal to 23.09. And there you go, 23.09 looks like 23.1 to me. Looks like they're rounding. Let's hurry through one more for the following figure. What's proper setup? They're saying sine trig function. Sine alpha equals op leg over height. How do we know? Because that's the SO in SOHCAHTOA, right? Sine equals op leg over height. We don't know the angle, so we have sine alpha equals the op leg across from this angle is 12 divided by 15. We're going to move over the sine function to a reverse sine function so we can back out the angle, and 12 over 15 here. Alpha is approximately equal to. So here's the right setup. We've got that going. But we're also going to plug this in quickly. Flip our calculator. Come on back. Let's clear this. And we're going to say second sine to the negative 1. A sine is what this is with the negative 1. 12 divided by 15. And parentheses equals, all right, 53.13, right, approximately equal to. So hope this helps. Find it on creatormath.com under the geometry tab under the unit on trigonometry.